rigid rod 50 mm in diameter is subjected to a pull of 50 kN. To what length the rod should be bored centrally so that total extension will increase by 15% under the same pull. Take E is equal to 200 giganewton per meter square.
Let us understand given question. We have to find out length of the bar which is bored centrally so that the total extension is increased by 15%. That means when this bar is not bored, that is for total solid bar which is having 50 mm diameter, the extension in this bar is equal to 100%. And when this bar is bored for a 25 mm centrally up to a length x, then the extension is equal to 100 plus 15, that is equal to 150. So we will first find out for the solid rod what is the extension in the rod. Now the data is given. The total length of this rod is equal to 3 meter. Diameter is also given 50 millimeter, and the tensile load which is applied on both sides is equal to 50 kilonewton. So we will write it into standard unit, 50 into 10 raised to 3 Newton. Young's modulus E is equal to 200 giganewton per meter square, and that is equal to 200 into 10 raised to 9 Newton per meter square. Now we will find out the value of delta L, that is for the solid rod what is the extension. So we have formula E is equal to stress by strain, that is sigma divided by delta L by L, and therefore the delta L is equal to sigma L by E. So sigma is stress, and we have to find out stress for the solid rod. So it's having formula P by A. So P is the applied force. So it is the tensile force applied 15 to 10 raised to 3, and cross sectional area. So for 50 millimeter diameter we have to find out the cross sectional area pi by 4 d square, where d is in meter, that is 0.050 square. So when we calculate, sigma is equal to 25.46 into 10 raised to 6 Newton per meter square. Now we will put this value of sigma in this formula to calculate delta L. So delta L is equal to sigma multiplied by length. So length of the solid bar is equal to 3 meter, and value of E 200 into 10 raised to 9. So delta L is equal to 0.38 into 10 raised to minus 3 meter. So this is the extension of the rod when it is not bored. So we can say that for 100%, so we have to write this given data as a for 100%, delta L is equal to 0.38 into 10 raised to minus 3. Now when this rod is bored, then for 115, because this extension is, this 100% extension is increased by 15, that is 100 plus 15. For 115 we have to find out the value of delta L. So if we observe here, we can cross multiply. So here is the unknown value x. So how to find out this x? So I will cross multiply 0.38 multiplied by 115 divided by 100. So it is equal to, so x is equal to 0.437 into, here we have to take 10 raised to minus 3 as it is, and this x is in meter, because if we observe this delta L is also in meter. So we can say that it is equal to 0.437 millimeter. We get the unknown value of x, that is the elongation of the rod when it is bored. So it is equal to 0.437 into 10 raised to minus 3 meter. Now if we observe the diagram when the rod is bored, now we have to find out the length of the rod bored for 25 millimeter. So this unknown value we will consider x. Now this length is in meter, so I will mention here the unit x meter. Now the total length of the rod is 3 meter. So if we observe, this solid rod is divided into two parts for the different cross-sectional area. So we will give the suffix 1 for the cross-sectional area with 50 millimeter diameter. So I will write here as a suffix 1. We will give the suffix 2 for the rod is bored 25 millimeter. So this is the different cross-section. So I will show here the suffix 2. Now we have to find out cross-sectional area at 1, that is A1. Cross-sectional area at 2, that is A2. We have to find out length, that is the length of the rod with 50 millimeter diameter, that is L1. We have to find out the length L2, that is for this suffix 2, that is L2. So from this diagram we will find out all these terms. So how to find out area A1? So I will write here A1 is equal to pi by 4 d square. So d is 50 millimeter, that is 0.050 square. So this is the area A1, that is pi by 4 d square. How to find out area A2? So area A2 is equal to pi by 4. Now this rod is bored, that is this material is removed. So we can say that this 50 square minus this 25 square. So we have to convert it into meters. So I will write here pi by 4 in the bracket, 0.05 square minus 0.025 square. This is the area A2. Now what is the length L1? So from this diagram, this length L1 is 3 minus x. L1 is equal to 3 minus x. And L2 is equal to, so length of the rod bored, that is equal to x. L2 is equal to x. So this is the unit having meter. So we get all the data. Now we can write here elongation after the rod is bored, that is, this is the value of delta L. Now this delta L is equal to delta L1 plus delta L2. So we have to find out delta L1 and delta L2 separately. So for this section 1 we will find out delta L1, and for this section 2, that is when the rod is bored, we will find out delta L2. Now how to write this delta L1 and delta L2? So that is sigma 1 L1 by E plus sigma 2 L2 by E, where the value of E, that is Young's modulus, is mentioned in the question. So main point is we have to find out stress in this section 1 and this section 2, that is the value of sigma. So sigma 1, that is P by A, that is applied force, which is 50 into 10 raised to 3 divided by cross sectional area pi by 4 into 0.05 square. So when we calculate, we will get the value 25.46 into 10 raised to 6 Newton per meter square. So we have calculated this value of sigma 1 for this solid rod. So we have to repeat this calculation, or we can write the value as it is. Now how to calculate sigma 2, that is P by A2. So same tensile load is applied, 15 to 10 raised to 3, and A2 is equal to pi by 4 in bracket. We have to write this value. So it is 33.95 into 10 raised to 6 Newton per meter square. Now we will write, or we will put the value of sigma 1 as well as sigma 2, then L1, L2 and this value of E in the formula, and we will find out the unknown value x. We will simplify this. So if we observe, delta L is equal to 0.437 into 10 raised to minus 3, and this denominator is common, 200 into 10 raised to 9. So we will transfer to the left hand side, and we will multiply this term inside the bracket. So if we observe, for both this term 10 raised to 6 is the common term. So we will take this outside the bracket. Now on left hand side and on right hand side there is 10 raised to 6 term, and we will cancel on both the sides. So remaining term is here 0.437 multiplied by 200. So here is 87.4. and this 76.38 we will transfer to the left hand side, so it will become minus, and this unknown term x we will add and subtract this coefficient, so we will get 8.49x. so x is equal to 1.29 meter. So answer is we have to bore this rod centrally for 25 millimeter for the length of 1.29 meter, so that the elongation after the rod is bored is equal to 0.437 into 10 raised to minus 3 meter.